look for a common factor. So let's look at these two. We have 4x squared and 36. Does anyone know what the largest number is that I can take out of both of these numbers? 4. Thank you. Thank you. So let's pick up our calculators. You do need a calculator, by the way. If you don't have one on your desk, go ahead, walk somewhere and grab one. Also look under your desk because it could be under your desk. All right, so let's pick up our calculators and divide both of these by 4 because that's my GCF. So when you divide 4 by 4, 4 divided by 4 is 1. X squared minus, what's 36 divided by 4? 36 divided, somebody on this side. What's 36 divided by 4? 9. Thank you. All right, so these two numbers are perfect squares, and it's subtraction. So does anyone remember from first semester, this always breaks down to a pattern. Anybody remember what that pattern would be? Yep, one of them is negative and the other one is positive. Good job. So we can put a minus in one and a plus in the other. Okay, what multiplies to give us 1x squared? The only thing that we can multiply to get 1x squared is x times x. So let's put a 1x in the front. And does anyone know what the square root of 9 is? 3, good. And what multiplies to give us 9 is 3 times 3. And this would be your final answer. This is completely factored. This would be a completely factored expression. All right, so we're gonna pick up where we ended yesterday in yesterday's video. Again, that is posted. It is the expectation that you watched it and took notes over it. I may come around a little later today and check your notes and give points for that because you should have graded, you should have watched that video. So before we start the new formula, let's go ahead and finish out the old. So we have in 2023, 11,000 students. There were 11,000 students in Pike Township. This number is growing at a rate of 4%. So in yesterday's video, I talked about exponential growth, which is 1 plus R. So 11,000, this would be my starting amount. The rate is 4%. And whenever you're writing a formula, before everybody starts copying down the exponential decay, I know this is there, but I need everybody's attention here, and you'll have time to write this down. But let's look here for a second. So we have exponent. This is my starting amount. This is the rate. So you always take the rate and divide it by 100. So can you pick up your calculators? Take 4 divided by 100. And you should get 0.04. So when you write it, when you write your model, these are the only two numbers that will be substituted. So the answer to part A is A equals 11,000. Then it would be 1 plus 0.04 to the power of t. Now t is years. And question B says, how many students will be in Pike Township in 7 years? So what you're going to do with your calculators is substitute a 7 for t. So pick up your calculators. The answer to part B is 11,000 1 plus 0.04 to the power of 7. So go ahead and type that in your calculator and see what you get. Now, because we're talking about people, whenever we're talking about people, we have to round it to the nearest whole number. You don't have this. Can I see the other side, this other page? Okay, so whenever we're talking about people, again, we don't include the numbers after the decimal. So if you typed it in correctly, this should be your answer. There will be 14,475 students. That's a 7 for T, because T is 7. You didn't see the 7. Okay, so go ahead. This would be your final answer. Raise your hand if that's the answer you got. So now we're going to move to exponential decay. So I'll give you a minute to copy this down, and then we'll talk about our second formula. So exponential decay, yesterday's video, we talked about growing at a percentage rate. Today, we're talking about decreasing at a percentage rate. And the big difference between the formula we did for number 3 and the decay difference is what? What do you notice the difference is between this formula and this formula? What'd you say, Juan? We put a minus sign now. So whenever it's going down or decreasing, we change the plus to a minus. A is still your ending amount. P is your starting amount. R is your percentage rate. And you always divide that percent by 100. And T is time. All right, does everyone have this new formula copied down? Anyone need more time? All right, let's move on to question 5 or question 4. Oh, was there a number 4? Okay, we're gonna skip 4 and go to 5, I guess. Let's go to 5. So it says the population of Anderson, Indiana is 15,000 people. So this is my starting amount. This is how much I'm starting with. The population, though, is decreasing, and it's decreasing by 6%. Take the 6, divide 6 by 100 with your calculator. And when you divide 6 by 100, we get that R is going to be 0.06. So our function rule will be A equals, substitute in 15,000, 1 minus 0.06 to the power of T. So what will the population be in 7 years? That means that T is equal to 7. T equals 7. So to figure out our population in 7 years, we have 15,000. 1 minus 0.06 to the power of 7. Go ahead, type that in. And because we're talking about people, we only want a whole number. So we can't have half of a person. We're either a whole person or we're not a whole person. Okay, so we don't need any decimal answers. So go ahead, type that in. And you should get, for number 5, 9,727 people. Raise your hand if that's the answer you got. Raise your hand if you need help typing that in the calculator. Me or Miss K can come around and show you how to type it in. Any questions? All right, let's look at question 6. So at an Indianapolis high school, there are currently 800 students. Again, this is how much I have now. That's my starting amount. The number of seniors that attend the homecoming school is decreasing at a rate of 3%. So because it says decreasing, we're going to use a subtraction sign. Take the 3% and divide that by 100. 3 divided by 100, and you should get 0.03. So in our formula, it's A equals my starting amount of seniors, 1 minus 0.03 to the power of t. That's your rule. And then it says in part B, at this rate, how many seniors will attend the homecoming dance in 10 years? So T is 10. So I'll give you a minute. Type that in your calculators, and then I'm gonna come around and see what answers we come up with. We don't technically round, so I would take 589 or 590 as the answer. No, because we're talking about people, right? And whenever you're talking about people, you're talking about seniors at a high school, which is people. We always have a whole number. So the answer would be 589 seniors. I would also accept 590 seniors. Any questions about that? All right, our last 2 questions. Let's look at number 7. So let's look at how the directions change. This says find the initial value, which means the starting value. This time they want us to find the start. They don't tell us the start, they tell us the end. And they want us to go backwards and figure out the start. So there are 50,000 people who live in Cruttsville. So 50,000 people who live in Cruttsville. That's my ending amount. That would be A. If 5% come to town, which means it is increasing at a rate of 5%. So R is 5 divided by 100. Go ahead, pick up your calculator, see what you get. You should get 0.05. How many people were there 10 years ago? So when it says ago, this is how I know I'm going back in time. I need to go back to the start. That's what it's asking me to find. So what does T equal? So Daniela, what do you think T is equal to? How many years are we talking about? 10 years, good. And we need to find P, so let's go ahead and do that. So the formula, we're going to have 50,000 equals P, because we don't know that, 1 plus 0.05 to the power of 10. So the thing to keep in mind is that this is a number. This is actually a number. And the operation that's happening between P and this number is multiplication. Do you see there's not a plus sign in between here, right? That's multiplication. So in order to solve it, I would divide. So I'm going to divide both sides. So what I'm going to type in our calculator, which you need to pick up your calculator, you're going to hit that fraction button, and it would be 50,000 divided by 1 plus 0.05 to the power of 10. That's going to give us P. Again, we're talking about people, so we need a whole number. It should be a number smaller than 50,000 because we're going backwards. So go ahead and type that in your calculator. Just like that, you're going to use the fraction button to see what you would get. Does anyone need help finding the fraction button? It says N over D. All right, who got 30,695? Good. So that means that 10 years ago, the starting population of this town 10 years ago was 30,695 people, and that was my start. So we didn't find the end, we had to go backwards and find the start. So we have one last question. Let's go ahead and look at that together. So we have a car that is currently valued at $35,000. Each year, this time is losing, so that means it's decreasing. Cars lose value. 5.25%. What was the car's original cost when you bought it 5 years ago? So we know right now, A, that's 35,000. Again, this word ago is telling me that I'm trying to find the start, which is our P value. So A is 35,000. R, you're going to take 5.25 and divide it by 100 in your calculator. Go ahead and do that to get your R value. And that should give you 0.0525. And it's 5 years ago, so T is 5. So our original formula would be, because this is a decreasing model, so this is my formula that I'm working with. So A, that's going to go here. So 35,000 goes here. R, that's going to go here. And T will go here. And we're going to divide again. This time, anytime you're trying to find the start, we have to divide. All right, so that gives us 35,000. That equals P. 1 minus 0.0525 to the power of 5. This is a number. We're going to divide both sides by this number. So 35,000 divided by 1 minus 0.0525 to the power of 5. Go ahead, type that in. And that's going to tell you the starting value of the car when you bought it 5 years ago. It should be a number bigger than 35,000. This time we are talking about money, so decimals will be allowed. So you should get 45,000 $832 and 33 cents. That is your starting amount. Any questions about how to use your calculator or any of the numbers we got? That's not what you got? Can I see how you type it in? 35,000. 1 minus. Oh, you didn't hit the exponent key. So you see how this 5 right here? That should be an exponent. So type it in again. Clear and type it in again. All right. Can everybody take out homework 1? Homework 1 is due on Monday, and I am giving extra credit for it today. So 1 minus 525. Close the parentheses. Hit the exponent key. That's what you didn't do on the last one. And then 5. So the last time you didn't hit the exponent key. All right, so let's talk about it together. Some of the common questions I'm getting about the homework. So you should be just about done with it. It's due on Monday, but I am giving extra credit for it today. So let's look at number 1. Question number 1 says y equals 3 to the power of x. So you're going to make your table. These are your numbers that you use. Anytime the base, if it's this number is bigger than 1, this is our table. Now, this is not going to fit. But does everybody remember how to put these in your calculator to get the y side? So you're going to hit 3, the caret key, -1. See what you get. 3, the caret key, 0. You don't have to write this part down. But as everybody know, this is the exponent key. So you're going to use that to get the y side. Okay, then you're going to graph it. For number 2, the base is 2. So you're going to do it again. You're using the same the same x values, but you're going to get a different set of y values because your base is different. Okay, when you get to 3 and 4, you're going to apply your transformations. Now flip it over to the back real quick. What's that first number? Is it number 6 that's on the back? The first question on the back? 7. So number 7, that's exponential decay. And can somebody tell me what it says? Does it say 0.25 to the power of x? Okay, this is an example of decay. So going to yesterday's video, When it's decay, we use different numbers. We just take all of these numbers on this side and we flip the sign. So it becomes -3. Well, I'll put them in order. So when it's decay, we're going to flip the sign of these numbers. So it'll be a +1, a 0, and then all of these numbers will become negative. Because it's decay. Whenever it's a decay function, we have to use different x values. And you're going to use the same table for 7. You're also going to use that for 8. I think 8 says 1/2 to the power of x, which if you look in your notes yesterday, I already graphed that. So you should already have this from the notes. So this was from the notes. All right, go ahead and use this time working on your homework. And we're not packing up. We all working on homework. We're going to take that on out right there. Thank you. We're going to work on our good old homework here. And then you're going to turn it in if you finish it by the end of the class period.